In this video, we're going to look at relative frequency. Relative frequency is closely related to experimental probability. I've just got three definitions here. If you can familiarize yourself with these definitions, it will help you in the questions which are coming up. Okay, so let's go through these. Theoretical probability is sometimes called the calculated probability, and it's using the laws of chance, i.e. the ratio of the expected number of outcomes over the total number of outcomes. For example, the theoretical probability of a head is half. Okay, so the experimental probability is the probability calculated through experiments. So if we tossed a coin 1,000 times, we might find that we scored a head maybe 49% of the time. And relative frequency is just the ratio of occurrence of a single event to the total number of outcomes. So if we tossed a coin 1,000 times and we got 490 heads, so we write this number of heads, 490 over 1,000 on this. Okay, and we can simplify this to 49 out of 100, which is 49%. Now let's look at a problem. Okay, so let's stick with the coin. A coin is tossed 100 times. Head appears 30 and tails 70. Okay, so is coin fair? Calculate the experimental probability of heads. And let's go for another question. Using your experimental probability, calculate the number of heads if you toss 1,000. Let's go for 1,000 times. Okay, so pause the video. Number 3 is an extension question. I don't expect you to be able to do it, but if you can work it out, that is brilliant. Pause the video and have a go at these questions. Okay, so is the coin fair? So I would say no, because you would expect heads to appear close to 50. Okay, so we have 30, which is 20 away from 50, which is significant given it is tossed 100 times. Calculate the experimental probability of heads. Okay, so we use our terminology. 30 over 100, which is 3 over 10. Okay, using your experimental probability, calculate the number of tails if you toss a coin 1,000 times. Okay, so we need the number of tails if we toss a coin 1,000 times. Okay, now I'm going to rub this out. I'll write this down at the bottom. Okay, much better. Okay, so we need the number of tails if we toss a coin 1,000 times, given the experimental probability is the probability of tail is equal to 7 over 10. Okay, there's a special formula for expected value, and it's the probability of x multiplied by the number of times the experiment happens. Let's not use the ruler there. Times, I'm going to say n. That could be p of x n. Okay, so let's do that then. The probability of x, which is a tail in our probability of tail multiplied by the number of times. So the probability of tail is 7 over 10 multiplied by 1,000. So we can cancel a 0. So we would expect a tail to appear 700 times. Okay, let's have a look at another question. Should not use the rubber. Okay, a die is thrown and the frequency of results is given in the table. Okay, so let's draw this table. Let's draw I quite like this. Okay, so we've got the number, and we've got the frequency 1, 2, 3, 4, 5, and 6. The die is thrown and the frequency of the results is given in the table. Okay, so let's get 4, 8, 9, 12, 20, and 30. Okay, so how many times is the die thrown? Okay, so you can work these out as I write them down. How many times is the die thrown? Calculate the probability of a 5 probability of not 5, and the probability of not even. Okay, pause the video and see if you can do these questions. Okay, so hopefully you've done that now. So how many times is the die thrown? So we call that n. We can say that is going to be the sum of the frequencies. So we're going to add all the frequencies up. So we've got 4 plus 8 plus 9 plus 12 plus 20 plus 30. Okay, 83. Okay, so we need to know the probability of a 5. Well, the frequency of 5 is 20 over 83. Okay, 20 over 83 does not simplify. Okay, now we need to know the probability of not a 5. Well, that is the same as, so that is 1 minus 20 over 83. Okay, so 83 over 83 is 1 minus 20 over 83. So that gives 63 over 83. Okay, and that does not simplify. Okay, so let's do the probability of not even. Let's start a new section here. The probability of not even is the probability of even minus 1. Well, this is even, and this is even. So we have 30 plus 12, which is 42. 42 plus 8 is 50. So we're left with 33 over 83. Okay, I think that's pretty straightforward. So just to recap, experimental probability is based on relative frequency. We conduct an experiment, that could be tossing a coin, rolling a die, and we complete a table of values for the frequency of events. Theoretical probability is the probability based on our formula in mathematics, the number of desirable outcomes divided by the total number of outcomes. Okay, I hope this is clear, and that we can now have a go at exercise 1202 on page 468.